Welcome back. In this video, we're going to look at solving more complex absolute value inequalities. Recall from the video before this, we defined two rules. We had a less than rule as well as a greater than rule. So we have one situation when we're dealing with absolute value expression less than a number, and we have another situation where we have absolute value greater than a number. Let's do an example. The first example we're going to solve the absolute value inequality. And we're going to make sure that we write our solution using interval notation. You'll notice here we have absolute value of 3x plus 5 is less than or equal to 14. So this is a less than situation. And per our rule, I'm going to drop the bars and add negative 14 less than or equal to on the right. And then we'll say 3x plus 5 is less than or equal to 14. So that's our setup. Now we need to solve this inequality. Now keep in mind, this is written in conjunction, and we have two inequalities occurring simultaneously. You don't have to separate it, but it does make more sense, and we will have an example here at the end where you do need to separate it. So I always just like to go ahead and separate it. So we have the first inequality, negative 14 less than or equal to 3x plus 5, and because we have the overlap or intersection, 3x plus 5 is less than or equal to 14. So I'm going to solve each of these. Here I'm going to have minus 5 from both sides. That's negative 19 less than or equal to 3x. Divide by 3, negative 19 thirds is less than or equal to x, or rather x is greater than or equal to negative 19 thirds. And on the other side, I will subtract my 5. That gives me 3x is less than or equal to 9. Divide by 3, x is less than or equal to 3. If we look at this on the number line and we try to think about where these overlap, we have to be less than or equal to positive 3, which goes to the left, as well as greater than or equal to negative 19 thirds. So the answer, my solution set, is the overlapped region. X is in the set from negative 19 thirds to 3. We have this closed interval here. All right, so that's our solution. I do like to separate it again because this conjunction, and when we're dealing with disjunction, sometimes what we have written on our paper doesn't make sense. Mathematically, that is. So I'm going to clean this up and just kind of show you a shortcut or shorthand notation in order to solve this. So the other way we could think about solving this would be just writing it all in one line and dropping those bars. So as it's all written in one line, you can kind of think about this as a balanced equation or inequality having three pieces. So the first thing I could do would be subtract 5 from either side. I've got negative 19. I'll write that in a darker color. Negative 19 is less than or equal to 3x is less than or equal to 9. Then dividing by 3. And we do that on each section. So I have negative 19 thirds is less than or equal to x is less than or equal to 3. You can clearly see that x is between negative 19 thirds and 3. So that's, albeit, a lot shorter. It's just when you use that strategy on a greater than equation, what you end up with is essentially a false statement because it can't be true like that at the same time. So let's look at another example. Here we have another absolute value inequality. We have absolute value greater than 4. So per my rule, the way I need to write this, because this is a greater than situation, I'm going to say that x minus 2 over 5 is greater than 4, or x minus 2 over 5, and that would be is less than negative 4. So that's the extra piece we do when we are dealing with a greater than problem. So solving each of these are pretty easy to solve. Over here, I'm going to multiply by 5. I have x minus 2 is greater than 4 times 5 is 20. I will add 2 to both sides. X is greater than 22. And on the other side, I have x minus 2 is less than negative 20. Again, I'll add 2. That's x is less than negative 18. So remembering this is an or situation. So that means it's either in the red region or the blue region. So I'll make my number line. I've got negative 18 and 22. X being greater than 22 is to the right of 22. X being less than 18 is to the left of 18. And you see that they are not overlapping. Again, this is an or situation. So we'll write our solution. We'll say that X is in the set from negative infinity to negative 18, union or 22 to positive infinity. And this is my end solution. So now you could use that same sort of shortcut here, but your answer, in a sense, isn't quite correct because it's written in conjunction, and conjunction means and you can clearly see these don't overlap. So if I asked you, where do these overlap? You'd say nowhere, and you might give me the empty set as a solution. All right, so just to reiterate what I just said, I'm going to clean this up. I could have written negative 4 is greater than x minus 2 over 5 is greater than 4. And so that is negative 20 greater than x minus 2 greater than positive 20. I'll add my 2. Negative 18 is greater than x is greater than 22. So when it's written in conjunction, technically that means and. I've got negative 18 is greater than x. That's the same as x is less than negative 18. And the second half, we would say x is greater than 22. And you can't be less than 18 and greater than 22 at the same time. So you'd have to know that this is supposed to be an or a union symbol. So mathematically, that's not exactly correct, but the shortcut does still sort of work. Let's look at one last example. So for our last inequality here, this is really a situation where we do need to separate. So we have absolute value is greater than, absolute value of 8x minus 1 is greater than 13x minus 2. So this is a greater than situation. We need to go and recall our rules. Is this an and or an or when we're dealing with greater than? And of course, because this is greater than, right, because we're dealing with greater than, we have this or situation. So we're going to take that expression, 8x minus 1, and it's going to be greater than 13x minus 2, or that same 8x minus 1 is going to be less than the negative of 13x minus 2. Okay, so greater than the positive of what we have, or less than the negative, the opposite of what we have. Greater than the positive or less than the negative. So I have two inequalities here that I'm going to solve. So on the left, I'll start combining like terms. I'll go ahead and subtract that 13 from both sides. So minus 13x minus 13x. That gives me that negative 5x minus 1 is greater than negative 2. Then I'll add 1 to both sides of the inequality. That's negative 5x is greater than negative 1. dividing by -5 on both sides. What happens when we divide by a negative number? The inequality changes direction, that sign changes direction. So I have x is less than positive 1/5. Let's look at the other side. Here I have 8x minus 1 is less than negative 13x plus 2. So now I will add 13x to both sides of the equation. 8 plus 13 is 21x minus 1 is less than positive 2. I'll add 1 to both sides of the equation. 21x is less than 3. And divide by 21 on both sides. That's x is less than 3 over 21. Or rather, x is less than 1/7. Remember, because this was greater than, we had an or situation. So it is either or one of these solutions. Let's think about using a number line to help us. So if I had 0, 1/7 is smaller than 1/5. So let's draw this. X is less than 1/5, as well as x is less than 1/7. Now, is this a overlap intersection situation, or is this a union everywhere that's shaded situation? And because it is or, it can be in the purple region or the red region. My solution set is that x is in the set from -infinity all the way up to 1/5, and that's an open interval. We do not include 1/5. Open means that's a parenthesis. And so there's my solution set. As always, if you have any questions, feel free to reach out. I am here to help, but that concludes our absolute value inequalities solving section. So have a great day.